This problem we are supposed to find the Thevenin equivalent for the circuit portion of the network to the left of the terminal A prime. So when we look at that, one thing to notice, I don't know if y'all have talked much about this, but the information, the reactances are given for the capacitor and the inductor. You see how it says X L1 equals 8 ohms and XC equals 4 ohms. So what that means is they've already done the part where you would say the impedance equals J omega L. They've already done the omega L part, and for the capacitance, where that would be minus J over omega C, they have done the 1 over omega C part. So that means that ZL1 is 8J8 and ZC is minus J4. So they've already taken care of the omega part and the fraction part. And so that's what the X part means. And ZL2 is J5. So this would be equivalent to if they had given us this Henry's, and omega just happened to be 0.159, because then if that were the case, or I'm sorry, if omega happened to be just 1. 0.159 would be the frequency. So like if they said the frequency is 0.159, then omega, which equals 2 pi, times the frequency would be 2 pi times 0.159, which would give you 1. And so then for the inductor, Z equals J omega L, I would get J times 1 times 8. And for the capacitor, Z equals minus J over omega C, I would get minus J over 1 times 1/4 would be minus J4. So all that is just to show you that some of the work has already been done for you. So that's what that is. Alright, so now let's move on. We're supposed to find the Thevenin equivalent. So let's start by finding V open circuit. So V open circuit is, if I take my circuit and I want to find out what V is across this terminal right there. So if it's open circuit, then there's nothing here. Then that means that this is not doing anything because there's no current flowing through it. And so the voltage across this terminal is the same as the voltage across this impedance. And that impedance is 3 minus J4. And this impedance is 6 plus J8. And so our V open circuit is 10 angle 0 times 3 minus J4 over 3 minus J4 plus 6 plus J8, which is 10 angle 0 times 3 minus J4 over 9 plus J4. And when I do that, I'll just go ahead and show you. Here's my calculator. I'll show you the next calculation. So this calculation turns out to be 5.08 angle negative 77.09 degrees volts. Okay, now we need to get R Thevenin, and so for R Thevenin you make voltage sources short circuits and you make current sources open circuits. And in this case I cannot ignore my other inductor over here because it is part of the total impedance over here. And so it's an inductor, so this is J5. This is, what did we say, 3 minus J4, and this is 6 plus J8. And so Z Thevenin is 6 plus J8 in parallel with 3 minus J4 in series with J5. So that would be 6 plus J8 times 3 minus J4 over 6 plus J8 plus 3 minus J4 plus J5. So now I will do 6 plus J8, 3 minus J4 over 6 plus J8 plus 3 minus J4 plus J5, and I get 4.64 plus J2.93. Okay, so what that means is my Thevenin equivalent circuit has a voltage of 5.08 angle negative 77.09, and it has a resistor of 4.64 ohms. And now the imaginary part is positive, so that corresponds to an inductor. So an inductor with XL equal to 2.93 ohms. And that's the end of that problem.